So far, we have established a secure mTLS connection using SPIRE between workloads inside a single cluster. Now we want to move one of the workloads to a different cluster and still establish the secure mTLS connectivity with minimal to zero code changes in it. And for this, we will first need to create two bundle endpoints for each of these clusters to federate with each other. To do that, we are going to use a service type load balancer for our bundle endpoint because we want to have an inbound route into the cluster, and a service type load balancer can enable us to do that. Our SPIRE server bundle endpoint will be a service on TCP port 8443. And let's apply this by doing a kubectl apply-f server bundle service YAML. And when we do a kubectl get service under the SPIRE namespace, we see that we have a bundle endpoint service that is externally reachable from this IP. I'll do the same on cluster 4 as well. Kubectl apply-f SPIRE server bundle endpoint YAML. And when we list services here, I have an external IP for this service as well. We'll begin by editing the server config map for cluster 3. So we'll define the federation structure inside this federation stanza. Our bundle endpoint that this SPIRE server serves will be listening on all of the interfaces on port 8443. And we will be federating with cluster4.demo trust boundary on this bundle endpoint at port 8443 again. We are going to use a standard SPIFFE bundle endpoint profile and expect the other party that we are federating with to have this SPIFFE ID to identify itself. Otherwise, we are not going to trust it and we are not going to federate with it. Then we'll apply this server config map, and then I'm going to kill the SPIRE server so that it can respawn itself, and it will initialize the API endpoint to federate the bundles. So let's do a kubectl delete po SPIRE server 0-n SPIRE, which will immediately delete the current server and deploy a new SPIRE server with the applied changes. And now I can telnet to this server's bundle endpoint, which is good. I'll do the same on cluster 4 as well. Again, I'll cheat a little bit and copy this federation bundle stanza and paste it on cluster 4's SPIRE server's config map and modify it slightly to match what cluster 4 needs. Instead of cluster 4, I'll use cluster 3 because we are going to federate from cluster 4 into cluster 3. And I think that's all that we need on this config map. I'll also need to change this endpoint IP, and I think we are all set. So let's apply the server config map here as well. Kubectl apply-f server config map.yaml, and we'll delete SPIRE server, kubectl delete po SPIRE server-n SPIRE, and then list the service endpoints again, kubectl get service-n SPIRE. Then I'm going to try telnetting to this external endpoint on port 8443, and it works. But for federation to work, there are a couple of additional steps to take too. First, these two clusters need to initially trust each other. To establish that trust relationship, we'll have to get the trust bundle of cluster 3 and add it into the bundles of cluster 4, and vice versa. We'll get the trust bundle of cluster 4 and put it into cluster 3. And once we manually add the bundles of the opposing clusters initially to each other, from that point on, the Federation API will kickstart and it will take care of the rest of the bundle sharing and certificate synchronization automatically. So to add those bundles to each other, I need to get the bundles first. And for that, we have this tiny print bundle script, which uses SPIRE server bundle show -format SPIRE command to dump the server's bundle in SPIFFE format. So let's see how it works. Yeah, it's a JSON file. So I'll copy this file and we are going to import it in the other server. And there are several ways to do this. And since this is a demo, I will just hack it a little. I'm going to first look into the persistent volumes of the cluster by doing a kubectl get PV, and then do a kubectl describe PV, and I learn where on my host machine this persistent volume that belongs to the SPIRE server exists, which is here. Then I cd into that var snap microcade this long volume string actually. And inside that folder, I will create a peer JSON, and I'll paste the content of the bundle file that I get from cluster 3 into the peer JSON file that I am editing in cluster 4. Then I'll save it. And that's for the virtual machine in cluster 4. To establish a peering relationship, we need to do the opposite in cluster 3 as well. So I'll export the bundle in cluster 4 and copy it over to the cluster 3's persistent volume and save it as a peer.json inside the same folder. And that folder is mapped to run/spire/data inside the SPIRE servers container. So let's execute this import bundle sh on cluster 3 and see what happens. And it says bundle set, so I think it's something good, I guess. And now we are going to do this on cluster 4 as well. Import bundle and bundle set again. We are almost getting there. Finally, on cluster 4, where we'll have the client application, we'll need to add the client application's SPIRE registration entry with this federates with parameter as well. So we are telling that this client application is going to federate with the cluster 3 demo trust domain. If we don't do this, the client application will not use the federated resources, so we won't be able to establish the secure communication that we want to. So we add this one, and we are also going to do the same on the server end as well. But let's start by registering the client and then show entries. And yes, our greeter client in cluster 4 will be configured to federate with cluster 3 demo cluster, like we see here. And we'll do the same on the greeter server. But right now we cannot do because we already have an entry for the server. So let's list the entries, get the ID of the greeter server's entry, and edit this delete script, paste the ID of the greeter server so that we can delete the entry related to the greeter server. And once we delete the entry, we can now register a new one. Then we can show the entries, and we see that the server on cluster 3 is federating with cluster 4.demo trust boundary, and the client on cluster 4 is doing the opposite. It's federating on cluster 3.demo trust boundary. So I'll delete the client deployment from cluster 3 so that it doesn't generate any noise. Then we'll tail the logs on the server. I'm going to add a bunch of blank lines so that we can see when new log entries approach to the server. And I'm going to deploy the client, the greeter client application on cluster 4. And then see if we can establish a secure mTLS connectivity. Fingers crossed. So I look into the deployment once more, and it looks good enough. The server's service address is matching where we need to communicate with, and the rest of the file looks fine to me as well. We'll build the client first, and then after we have the client inside the registry, we'll do a kubectl apply -f greeter client.yaml, which will deploy the greeter client application onto cluster 4. And when we tail the logs of the greeter client, we see that both greeter server and the greeter client are happily as a clam talking to each other, and they can see each other's identities, they can verify each other's identities and accept or reject connections based on whatever policies that they deem necessary. And that finalizes our series on how to establish a secure federated mTLS connectivity between two workloads inside two distinct Kubernetes clusters using SPIFFE and SPIRE. For more details on federation, SPIFFE, zero trust, turtles, check out this video's webpage. And until next time, may the source be with you.